Hey guys. All right. So here is our next skill that we're going to be talking about. Yesterday we talked about multiplying exponents. And so today we are going to be talking about dividing exponents. Okay. So, yeah, let's go ahead and get started. These are our four things we're going to talk about. So we have quotients of powers, power of a quotient. So if you think back to that vocabulary, quotient means the answer in a division problem. Okay, so when you see quotient, just know that that means we're talking about division. The zero exponent and negative exponent. So really there's only two that have to deal with division, and then the other two kind of work with both. So we're just going to be talking about both of those. All right, so let's go ahead and get right into it. Remember that you need to be writing these notes down, and you have to turn in these notes for your grade to know that so that I know that you're doing it. Okay, so don't forget to not only write them down but also turn them in. Okay, so the first one we're going to be dealing with is the quotient of powers. Okay, so this works for any non-zero number, so any number that's not zero, and any integer m and p. So remember, integer is a whole number, so like 1, 2, 3, -1, -2, -3, those are integers. Okay, but it can't be zero. All right, so I went ahead and wrote out this little definition for you, so let's look at it. So again, this counts if you are, this counts if you are dividing two powers with the same base. So remember, base is just talking about the variable. So if they're the same variable, what you'll do is if you are dividing and they are the same variable, you are going to subtract the exponents that's in the denominator from the exponent in the numerator, and you'll keep that same base. Okay, so no, that's a lot of information, so let's look at an example. All right, so we're looking at this example right here. Okay, I'm going to try to keep my colors a little more organized this time. All right, so we'll look at this example right here. Okay, so the first thing I notice is it is a division problem. Okay, so I can see that by this fraction bar here. That means I'm going to divide. All right, yeah. All right, so then I'm going to look for numbers that have the same base or the same variable. Okay, so I have a g and a g. So what my rule tells me to do down here is that if they have the same base, then I'm going to subtract their exponents. Okay, so I'm going to keep the same base, g, and then I'm going to take this exponent 3, and I'm going to subtract this exponent. So I know you're thinking, well, that one doesn't have an exponent, but we know from our last lesson, if it doesn't have an exponent, it's understood to be 1. So that would be 3 minus 1. Okay, so now let's look at the next one. I see I have this base and this base or variable the same. So we'll keep that same base, and then we'll take its exponents, and we are going to subtract them. Okay, so obviously we're not going to leave it like that. We need to simplify it. Okay, so I'm going to bring down my g. 3 minus 1 is 2. And then bring down my h, and then 5 minus 2 is 3. And again, we're just simplifying. We're not actually solving anything. Okay, so that is how you do the quotient of powers property of exponents. Okay, now not too bad. Okay, so if it has the same base, so if you see a g and a g, or an x and an x, or an a and an a, you're going to take those exponents and subtract them from each other. Okay, that's all that rule says. Okay, let's look to the next one. Okay, so this one, if you want to pause the video, is called the power of a quotient. Okay, so again, a quotient just means it's a division problem. Okay, so that could look like a fraction. All right, and so basically you're taking a fraction to a power. Okay, it's raised to a certain power. Okay, so again, this is for any real number that's not 0 and it's an integer. So again, positive 1, 2, 3, 4, 5, 6, 7, and so on, and negative 1, 2, 3, 4, 5, and so on. Okay, so right here you can see the example that it gives you. It's written like it's a fraction. Okay, so if we knew that a equaled 1 and b equaled 2, that fraction would be 1/2, right? Okay, so it's basically just saying that you have a fraction raised to a power. So if you ever see that, then what you have to remember to do, it's kind of like the rule we talked about yesterday when there was something inside of the parentheses that's being multiplied. We learned that you have to take your exponent and you have to distribute it. Well, the same is true for if it's a division problem. You have to take that exponent, distribute it not only to the numerator, but also to the denominator. Okay, so I wrote that down here. So if a fraction is getting raised to a power, you're going to distribute the exponent through both the numerator and the denominator. Okay, so again, you need to pause the video and write that note down because that's an important fact about the power of a quotient rule. Okay, so once we have distributed that, if we distributed that exponent through to the a, that would become a to whatever power. And then if we distributed it to b, it would be over b to that power, that same power. Okay, so you can see this one's a little different from the other one because now we're working with different bases, okay, different variables. Okay, so we couldn't just take our exponents and subtract them. Okay, we're working with two different variables. Okay, all we're doing is now taking a fraction and taking it to a power. Okay, so let's work an example because that always helps to work it with actual numbers. Okay, I'll use purple. Okay, so this is our example. Again, make sure that you're writing all of these down in your notes. Okay, it helps just to write it down instead of just watching me explain it. Okay, so what I notice is I have a fraction here. Even though it's a little bit more complex than what we're used to seeing, it's still a fraction because of this little division bar here. Okay, so I see that this fraction is being taken to a power. So what do I have to do? I have to distribute it to everything in the numerator and in the denominator. Okay, so that's going to be 3 squared, and then we have p to the third power squared. Okay, so this is a little bit going back into what we talked about with multiplying exponents. When you have an exponent being raised to another exponent, what do you have to do with them? You multiply those two. Okay, so that's going to be p to the 3 times 2 power. Okay, and again, this is one extra step I'm just showing you, and then we'll simplify it at the end. Okay, and that's all over, so we have to still remember to take that exponent that's squared and distribute it also to my denominator, so that would be 7 squared. Okay, so now let's simplify everything. 3 squared, that's 3 times 3, so that's 9. And then we just keep the same base here. 3 times 2 would be 6. And all of that would be over 7 squared, which is 49. And again, we are just simplifying. We cannot simplify any more than that. So we would just leave it like that. Okay, not too bad. And again, we're going to practice a lot more of these, so don't stress about it. Also, if you have questions, please send them to me. Don't stress. Don't give up. Ask me questions, okay? That's y'all know that I want to help, okay? Next one. This one is the zero exponent. This one will probably be your favorite, and you will see why. All right, so again, this is for any non-zero number, period. Okay, so this works for fractions, whole numbers, all the numbers except for 0. Okay, so if a number is any number, here's the rule. Make sure you pause the video and write this down. anytime a number is raised to the 0 power, it's always going to equal 1. Okay? Always, no matter what, any number ever, fraction or whatever, fraction or whole number, it will always equal 1. Now, you would think it's gonna equal 0, but it doesn't, okay? And you can even test it into your calculators, whatever you wanna do, but it's always gonna equal 1, okay? So, right here. So we have 15 to the 0 power. You guessed it, it's gonna be 1. You have some fraction raised to the 0 power, it's gonna equal 1. Okay, we had 3/4 to the 0 power, 1. That looks like a 6. 0. Okay, you have 247 to the 0 power, 1. Okay, so that's the 0 exponent rule. Anytime it's raised to the 0 power, it's going to equal 1. Okay, so that's just something you're going to have to remember. All right, last one is the negative exponents. Okay, so this is for any non-zero number that is your base, and it's an integer. So again, just like the first two, it can't be, your base can't be 0, and it has to be a whole number. It can't be a fraction. Okay, so basically how this one works, it says if you have a negative exponent, what you do is you will just flip the numerator and denominator, and the exponent will become positive. Okay, so you take whatever's in the numerator, whatever's in the denominator, flip it. If you can remember what that's called, you get pat on the back because really can't do anything else, but it's called a reciprocal, and then the exponent becomes positive. So let's look at an example here that they give you, which I know that y'all don't like it when it's just in variables, because I know that I did not like it like that when I was in school, but let me explain that and then I'll give you one with numbers. Okay, so say we had a base A and it's to the negative exponent. Well, we know that a whole number, because that's what it has to be if it's an integer, we know that that's understood to be over 1. Any whole number we know is understood to be over 1. Okay, so since it has a negative exponent, what we're going to do is we're going to take the number in the numerator, that whole number, and then we're going to switch it with the denominator. Okay, so now that equals, my denominator is 1, that now becomes my numerator, and then my a to the n power is now in my denominator, and then you can see that the exponent is positive. Okay, so I've wrote down a couple examples with numbers so that you can see that with actual numbers and variables. Okay, so let me just kind of mark some space off here so it doesn't all bleed together. All right, so this can be example 1. Yeah. All right, so we have x to the negative 1. Okay, so you're taking some number and you're taking it to the negative 1 power. Okay, so what does that mean? Basically, you're going the opposite way. Your number's not getting bigger, it's getting smaller. Okay, we're used to exponents making numbers bigger, but a negative exponent is going to make it smaller. Okay, so we know that this whole number, whatever it is going to be over 1. Okay, so if we were to take the negative exponent of that, then we're going to have to switch these two things. So my denominator now becomes my numerator now becomes my denominator, and then my exponent is going to be positive. Got it. All right, let's do one more, because this one can seem a little bit more confusing than it is. All right, let's do all numbers. So we have 4 to the negative 1 power. Okay, so we know that this 4, it's a whole number, it's understood to be over 1. Okay, so we are going to take the negative 1 exponent of it. We have to take this numerator and denominator and flip them. Okay, so that's going to become 1 over 4, and that 1 just becomes a positive 1, which just, you don't even have to write that. You can just leave it as 1/4. So just like I said earlier, our number or our base is not going to get bigger like we're used to with positive exponents. It's actually going to get smaller, okay? Like your decimal is moving in the opposite direction. All right, so that is how you would do the negative exponents property. That is the end of your notes, so make sure you get all of those copied. Make sure they're neat, nice, and organized. Make sure your name is on it, and take a picture of it. You can either post it into the Google Classroom assignment, you can send it to me in a remind, or you can send it to me in email, whichever one is easiest for you. I will see it, and I will give you your grade. If you have any questions, attach that question when you send in your notes, whatever you need to do. All right, I will see you guys in the next video, I guess.